Hello everyone. Okay, so in today's video we are going to be going over circle theorems. So these are key theorems in the geometry chapter. So theorem 19 is the angle at the center of a circle, and then we have three corollaries that follow from this theorem. So let me just name this theorem first, and I'll show you bits on GeoGebra and then we'll answer some questions. So what is theorem 19? So angles at the center of a circle. So the angle at the center of a circle standing on a given arc is twice the angle at any point of the circle standing on the same arc. A lot of words. So what's that mean? So see here, right? See here, the boat standing on this purple arc here. This is my center. Basically, if I connect 2 points to my center here, any other point that I make from the same arc that touches the outside circle is going to be half that, half the inner circle. So let's have a little look in GeoGebra at it. So here's the theorem here. So if you can just see here, I just zoom in a little bit, ding, ding, ding. Gorge. Right. If you see here, if I move this arc, it changes, right? So looky here. So this is 68, 34, right? And no matter where I put it, it'll still be 34, right? And again, if I change my arc here, if I give myself an obtuse angle like this, no, a reflex angle, I should say. A reflex angle. This is 275. That's going to be half it, which rounds to 138. But primarily, we're going to be doing ones like this. So if it's 88 here, it's going to be 44, right? No matter where I go. Now, one of the corollaries we derive from this theorem is, what if my arc is the diameter, right? So let me just put this here. There we go. So now my arc is on the diameter. This is now my center angle here is 180. Now, if you look here, any angle on this semicircle is going to be 90 degrees. No matter where I put it, it will always be 90 degrees. So that is corollary 1. Or corollary, yeah. No, it's going to be, that's corollary 3, right? So angles on the diameter. So each angle in a semicircle is a right angle. So that's an important one to know. Corollary 2 here is all angles at points of the circle standing on the same arc are equal. So if you see here, both of these are standing on this same arc, right? So let me just change the color here. So they're both standing. The blue and the yellow angle are both standing on the ends of this arc. So therefore, these angles are equal to each other. So let's have a look in GeoGebra. And let's have a look in GeoGebra and see. Right. Go down. There it is. So, angles on the same arc. Right? So no matter where I move the arc, that's going to be 28. That's going to be 28. Right? Can I zoom in a little bit here? I can indeed. Right? So if I change my arc, make it really big like here. So the boat starting here. So this one joins here, this arc, and then this arc here. 65, 65. No matter where I put it. If I put it here, right? This arc here, ding, dong. Right? This one, bing, bong. Same. So if two angles are on the same arc, they are equal to each other. And then finally, our last corollary here is to do with cyclic quadrilaterals. So if I have a quadrilateral shape in a circle where each corner is on the circle, right? So see here, each corner is on the circle. There's a special property. Opposite angles are going to add up to 180. So, for example here, if I'm going to move this a little bit here. So I'm moving this now, changing the angles on my yellow ones. So if I move this here, let's say, this is 132, this is going to be 48. Add them together, 180. Right? Put this here like this. 114 plus 66, 180. 111 plus 69, 180. So no matter where I put these corners on my circle, opposite angles are going to add up to 180. So 115, 65. 65 plus 115, again 180. What's down here? 78 plus 102, 180. So no matter where I put these on my circle, the opposite angles will equal, when summed together will equal 180. So there are 4 main circle theorems, and you need to be flexible with these theorems and be able to recognize them when given to you. So let's just do some examples here. So this is from the 2014 exam paper. P, Q, R on the same points on a circle with a center, or some points on a circle with a center 0. P or S is equal to 32 degrees. As shown, find SOP. SOP. We're trying to find this angle. Well, what do we know about angles at a center? Right? It's going to be double the angles made on the same arc anywhere on the circle. So that's going to be double 32. So that's going to be 32 times 2, which is going to be 64 degrees. So this is going to be 64 degrees because it's double that 32 there. Find angle SQP. So SQP, this angle here. Well, if we're lucky here, they're both on the same arc, right? So they both start at point S and P. They're both on arc SP. So therefore, if they both start on the same arc here, we know they're equal to each other. So that is going to be equal to 32 degrees because on same arc. Easy as. Easy as. Let's do a few more examples. Angles ABC and D are points on a circle shown below. AC and BD are diameters of the circle. Prove that angle ABCD is a rectangle. So, BD, that is the diameter of my circle. So therefore, if you're looking here, this arc here then must be 90 degrees. And same here. This angle here then must be 90 degrees. Using my theorem of angles on a diameter make 90 degrees. So they're about 90 degrees. Stunning. Right? They're about 90. Therefore, these two angles here, again, if I look here, that lies in this arc here. So that's going to be 90 degrees. It lies on my diameter. And then same here. Right? That's going to lie on my diameter. So therefore, I've proven all angles are 90 degrees. Therefore, it must be a rectangle. And that's it. Easy as. Right? So you just need to write that down. All angles are 90 degrees because angles made on a diameter are 90 degrees. Let's have a look at this one. Work out the value of x. So I have seen here AB is the diameter of the circle. Now it doesn't really give me a point AB, but we're just going to assume that's A, that's B. Right? I probably just missed it when I was typing this out. That's A, that's B. That's my diameter. So we want to find out what angle x is. Well, first of all, I know that this entire thing here will be 90 degrees because it's on my diameter. But that's no help to us so far. So let's see, can I figure out anything else? Let's see if I can figure out what this little angle in here is going to be. I know what this angle is going to be. Because angles on a line add up to 180. That's axiom 2 or 3. It's one of them. It's one of the axioms anyway. So if this is 61, therefore the angle in here must be 119. 119. Now I have this triangle here. So if you can't see it, here's a triangle here. I have, boom, So that's 34, that's 119. Therefore, this angle must be equal to a number. I don't know what it is. I'll tell you now in like 10 seconds. 27. This is going to be equal to 27. And then we know this sum is to 90. So 27 plus x has to equal 90 degrees because that entire angle is equal to 90 degrees. X is going to be equal to 63 degrees. Therefore, I figured out what x is there. Okay, so let's have a look at this question here. So P, Q, R, and S are 4 points on a circumference of a circle. PR meets QS at A. So angle PRS is equal to 57 degrees and angle PAQ is equal to 78 degrees. Work out the value of Y, including your method. So, what other information do I have on this? Nothing much, really. So I want to find out what angle Y is. So let's see, is it standing on the same arcs? It seems to be standing on an arc QR. Seems to be standing on that arc there. So what else is standing on that arc? Well, I can just see angle S stands on that arc. So maybe finding what angle S is will help me derive what Y is. So for now, I know Y is equal to angle S because same arc. Well, I know this angle is going to be 78 because opposite angles are equal to each other. So QAP is going to be equal to angle RAS, opposite. Therefore, and also then, angle S is going to be equal to, well, 57 plus 78 minus from 180. Which is going to be 45 degrees. So I know angle S equals 45 degrees, which implies Y is equal to 45 degrees, because that was the first thing I mentioned there, because they both lie on the same arc. Right, let's have a look at another one here. So A, B, C, and D are 4 points on a circle as shown. AD bisects, it's a important question, bisects angle BAC. P is a point of intersection AD and BC. Show that triangle ADP and APC are similar. So I need to prove ADB, so this triangle, here is similar. So they have the same angles. Okay, this is not playing with me. There you go. Has the same angles as APC. APC, this one here. So if we look at here, let's see what angles we can prove here. So it says here, BAC is bisected. So BAC is bisected. So therefore, this angle has to equal this angle because AD bisected it, cut it in half. So that's one sorted. I need to prove as well. So I've proven they are equal to each other because it's bisect. That's given. That's given to us. So angle BAP is going to be equal to angle PAC because it's given in the question. So let's again have a look. Let's see now, do they stand on the same arc? Right, so let's have a look here. Does this angle stand on the same arc as anything? So that angle seems to stand on the arc AB. Does anything else stand on that arc? Well, I see angle D stands on that arc. So therefore, them angles are equal. And since them angles are equal, therefore, that implies that the final angles here have to be equal to each other. So angle ADB is equal to angle ACP because they're on the same arc, and then which implies that the remaining angles are the same. So ABD, angle ABD is equal to angle APC. So it implies that because the other two are the same. And finally, show AC times BD is equal to AD times PC. So this is a tricky one. So you might think, oh my God, no, we're doing here. We are dealing with similar triangles, ladies and gentlemen. So we're dealing with similar triangles. We have to remember my ratios when it comes to similar triangles. So with similar triangles here, so this side was A, that was B. This is D, A, C, P. So I know, sorry, I just rubbed all my workings out there. Ding, 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 ding. Right. So I know this angle is equal to that angle. So APC. So I know this angle is equal to this angle. So I want to prove that AC times BD is equal to AD over PC. So let's use my rules of similar triangles here. So this side, the one between the double and the single angle here, corresponds to this side. So PC corresponds with BD. So A, B, D, A, P, C. So 1, 2, that's D, 1, 2, and then these are the same. So this side corresponds with that side. So I know PC divided by BD, that should be equal to PC over BD, that should be equal to AP sorry, PC over BD, that should be equal to AC, right? Because between the dot and the line, so dot and the one line, all over AD. I know they're equal to each other because they're similar. Cross multiply. PC times AD is going to be equal to AC times BD. And therefore, I've proven what they were asking for in that there. So I just multiplied both sides by BD and AD, and that I left with that there. Sorry guys, that was not my best. Very low energy. It's like 2 in the morning. Anyway, I will catch you guys later. Hopefully this was some sort of help, and I'll catch you on the flip side. Bye.